Alright guys, today we're talking about proving parallel lines. So in our last video we talked about same side interior corresponding alternate interior and alternate exterior angles. So we'll be using that a little bit today. First things first, we have some vocabulary terms that we need to go over. The first of them is being parallel lines. Okay, parallel lines have the same slope. And in the figure below, you'll see that line L and line M have these little tick marks to show that they are in fact parallel. So we use those little arrows right here and here to indicate that they are in fact parallel. Without knowing the exact slope, you have to have these arrows before you can say that they are parallel. Alright, so before we get started, on the actual proving part, we need to actually be able to construct a parallel line that's parallel to M, but goes through point P. So the first things first that you need to do is you need to connect point Q to point P. Okay? Alright, so here you've seen that I have used my ruler to construct the line QP. Now what you're going to do is we are going to copy this angle Q onto point P. So create an arc at point Q and do the same thing from point P. Okay, so this is kind of upside down from what we're used to. But remember, when we measure an angle, what we need to do is actually put our compass on one side of the ray and measure the width with the other side of our compass. So we're a little close. Let's see if that, alright, that's close. Put it here, put it right there. And we make another arc from here. And now all you have to do is connect point P with the intersection of the two arcs. Alright, so I've connected point P with this arc, the intersection of the two arcs. We can call that line L, and we can say that line L and line M are parallel by construction. These angles being the same are what we call corresponding angles. And remember, when we have corresponding angles congruent, we can say that the lines are parallel. So that's how we can say. Alright, so why does it make sense to copy PQR to get line parallel to line M? So I kind of basically already touched on that, because basically if the corresponding angles are congruent, then we know that the parallel lines have to be congruent. Alright, is it possible to construct a line parallel to the given line M that passes through a point P that's on line M? Well, if the line goes through point P and touches M, it can't be parallel. So it says here that it passes through point P that is on line M. So if this point P here was on line M, then isn't line M the only parallel line I can make? For example, I'll draw a picture. Okay, so here's my diagram, and let's say that this point right here is point P. I can put this point anywhere and do the same process as I did on the previous slide. However, let's say that point P is on line M. Okay? In order for a line to go through point P and be parallel, it's going to be the exact same line. The only line that's parallel to line M and goes through point P is line P itself. Alright, so remember that when we're proving parallel lines, we have a couple of items here. Okay, if we have corresponding angles congruent, okay, notice it's if, then, so we're having conditional statements here. If corresponding angles are congruent, or if alternate interior angles are congruent, or alternate exterior angles, or, now these say consecutive interior, we call these same side interior. Okay? Either would be acceptable. And then also if the lines are perpendicular to the same lines, then we know that the lines have to be parallel. So let's take a look at these two parallel lines. It says we need to tell whether lines M and N are parallel given the following information. If they are parallel, we have to state how we know how. We can't just say yeah or no. Okay? We have to explain. So for problem number 1, it says that we know angle 7 and angle 3 are congruent. Okay, we can say yes, those would be congruent by the alternate interior angle theorem. For number 2, it says angle 7 is congruent to angle 6. So we're going to close that out here and here. Okay, remember that same side interior angles are not congruent, they're supplementary. So we can't make any assumptions here. What if they're both 20 degrees? Then it only adds to 40. So we cannot say they're parallel. And then number 3, it says angle 1 and angle 5. So we have angle 1 and angle 5, and those would be alternate exterior. So we can say yes by the alternate exterior angle theorem. Alright, so a few more examples. I want you to give these 3 a try, number 4, 5, and 6, and pause, and then we'll talk about it. Alright, so angle 5 and angle 7 is what we're given are congruent in question number 4. Yes, these are corresponding angles, and if we know they're congruent, then the 2 lines are parallel. So yes, by the corresponding, I'm going to write corresponding down here, corresponding, long word, angle theorem. Alright, now we are given that angle 3 is 15x plus 22, and angle 1 is 19x plus 10, and that x equals 8. So plug it in. 15 times 8, let's do it here, 15 times 8 plus 22 tells me that the measure of angle 3 is 142 degrees. Alright, so do the same work here. It says 19 times 8 minus 10, well, that's 142 as well. So what I can say here is that these 2 angles are in fact congruent. So we could say angle 3 is congruent to angle 1. So angle 3 is congruent to angle 1. And since they're corresponding angles, the lines have to be parallel. So yes, by corresponding angles again. Okay, so if for some reason you didn't pause and try 4 and 5, I want you to pause here and do 6. It's very similar to number 5. So go ahead and pause and try number 6. Alright, so we need to plug in 9 for x, so 6 times 9 minus 1. Okay, that gives me 53. And then 5 times 9 plus 3 gives me 48. Since angle 8 is not congruent to angle 4, we can't say these are parallel. There's not enough information, okay? If I knew that they were parallel, 8 and 4 are alternate exterior, but we can, obviously they're not congruent, therefore the lines are not parallel. We can make that assumption. Alright, that's all we have for today. Okay, and I will see you tomorrow.